Hey everyone, welcome. We're going to give folks just another minute or two to join, and we'll go ahead and get started. All right, let's go ahead and get started. So I'm Ryan. I'm the head of product here at ObserveIQ, and this is our Mastering OpenTelemetry series. So hopefully you've been following along. I think we're on our fifth webinar now. We started with just an intro to OpenTelemetry, and we've gone through building a collector and building pipelines, a deep dive on the various components. If you've missed any of those, please let us know. We can send you links to the past recordings. We will also have a hub up on our website pretty soon that will have recordings of the entire series. So today we're going to be talking about managing high volumes of telemetry with OTel. And so if you have any questions as we go through, please don't hesitate. We'll pause and jump into your questions throughout the webinar. And with that, I'm going to hand it over to Mike to get started.
Thanks, Ryan. Thanks for joining everyone. And like Ryan mentioned, please feel free to throw any questions that you have, even if it's before we get started in the chat, and we'll try and answer as many of those as we can. But like Ryan said, we're talking about managing high volumes within OpenTelemetry. And this is, a challenge that nearly everyone dealing with telemetry at scale has experienced. And OpenTelemetry makes it pretty easy to handle, or at least relatively easy compared to the other options you have for managing massive amounts of telemetry data. So we're going to talk through a few of the scenarios that we want to look at, different areas where scaling can become a focus, ways that you can scale, strategies you can take. Then we'll talk a little bit about how we do that in BindPlane as well, to give you some real examples. This is just a reminder and a simple OpenTelemetry observability pipeline. There's a decent amount of detail in terms of how you build this, the configurations for individual components that's available in the last webinar. So if there's anything that feels like a gap, I'd recommend check that out and see if it fills in any of those points. So I want to focus mostly on architecture and how we scale out and the recommendations and best practices for scaling out with OpenTelemetry when you run into scale challenges. So just the basics here, we have in a typical OpenTelemetry observability pipeline consists of multiple agents and gateways. In the simplest version, you have an agent collecting metrics, traces, and logs. Could be on a host with a custom application. Could be in a Kubernetes environment. You have multiple gateways, and we have a gateway group here that's behind a load balancer and scaling out. We'll talk about that. And then we're routing telemetry to your destinations. This could be SIM, APM, cold storage, really any potential destination for your telemetry can be handled in this architecture. We also can pull in sources from other non-OpenTelemetry agents, as well as if you're doing things like ingesting syslog or scraping Prometheus metrics from a different location. That can all be handled in this architecture as well. And we try to do most of the processing in the collector gateways. So at least as we're offloading work. So we can do this in the agent, but if it becomes a concern with compute, or if you're consuming too many resources on your host, then we shift it over to the gateway. So that's the general architecture that we've talked about. But now we'll talk about what it looks like when we start to scale and some of the challenges that you run into. First of all, some general best practices. One is what we just talked about. This agent gateway architecture is a really easy to scale architecture that we recommend to anyone trying to implement this that expects to have high volume or is focused on resiliency and high availability. So we use agents, gateways, and then auto-scaling gateway groups. So what we're seeing here is an auto-scaling gateway group behind a load balancer. We also want to reduce any data that we don't need, filter out unused data, compress it when possible. And we want to do that at the earliest stage possible. So when you're dealing with high volume, dealing with a lot of telemetry, the sooner you can drop that data that's not going to be needed, the better. Otherwise, you're simply increasing the processing, the network traffic at every stage through that pipeline. And this is, can be in contention a bit with the previous point, right? We also want to minimize processing at the agent and move it to the gateway. But we only want to do that when it's going to impact a host workload. So we're going to reduce and filter as soon as we can. But if that reduction or if that processing has any impact, then we can move it out to the gateway. We also want to consider the workload location, physical location, and also how you segment telemetry. And we'll talk about that a little bit later. But, it's something worth paying attention to, where your gateways sit, where the workloads tend to reside, and understand the impact and the distance or latency in those requests. It's also good to think about how are we breaking apart telemetry. So it's not a single pipeline, but it could be broken down by application or team or region, or it can actually be broken down by telemetry type as well. So I want to go through a few simple scaling scenarios at different stages in the pipeline. One, and the first one is you have an OpenTelemetry agent. This is, in this instance, it's running on a host with the application that it's monitoring. And you can see a couple of potential issues. One, there's so much volume, so much telemetry coming through that the processing is hitting an unacceptable level or unacceptable resource utilization on that host. So it might be impacting the application that's running, or if this is a separate agent on its own host, it may just be going beyond the capabilities of that instance. So depending on what that is and the reason for it, there are a few different ways that we approach it. If you're doing a lot of processing and that seems to be causing impact on that host, then we're going to move as much as needed to the gateway. So just like I was mentioning, if we see an impact in performance, we want to move any of the processing or compute intensive operations out of that agent and into the gateway. Because the gateway can scale out, the gateway is going to be built on its own instances. It's not going to impact anything else completely separately. The next is, if it's volume related. So this might be if you have a lot of metrics logs. Frequently this will happen with logs. If you're just ingesting massive amounts of logs, it can be a volume related challenge where you may run into those same issues, but just the amount of telemetry that you're collecting and transmitting becomes a challenge. And so for that, we will frequently recommend moving the agent to either dedicated host, a sidecar, or to a different, but ultimately in a different isolated instance, and then accessing those logs or metrics outside of the host. And that'll usually solve that. And I'll comment, we're talking about the impact of the agent on a host. The agent itself is highly efficient and is capable of pretty high throughput. So we don't run into this in a typical scenario, right? You need to have a pretty extreme scenario for this to be a significant impact on a host. The last item is, and this is, I'd say, most frequent with Prometheus metrics. If you're collecting a lot of Prometheus metrics, that's a common scenario where you have an OpenTelemetry collector running as agent, and it's scraping, maybe a number of different Prometheus endpoints, and that volume gets to a certain point where you need to scale behind a single host. The recommendation for that is to take those metrics, shard it into different segments, and then applying it to multiple collectors, applying different configurations to multiple collectors. So you're separating out the data. There's also a special utility that's available within the OpenTelemetry contrib repo that will automatically do that sharding for you. But we find the simplest way is just to break this up amongst configuration files and then separate out and run multiple agents to gather Prometheus metrics. And again, that's the most common scenario, but it could be anything that you're collecting metrics or logs via an API could be a similar scenario. And one thing I wanted to jump into the benchmarks, because this is useful. If you're asking yourself, well, how often is this going to be an issue? And when will I need to scale out? When will the collector become hit a level of resources that's going to be a problem? In my instance, there's a full suite of benchmarks that are released and go out, run every time there's a new commit on the collector and every release. And so you can go through and get really detailed information on CPU usage in various scenarios with different receivers and exporters, and get a sense of what that impact could look like under heavy load. So if that's something that you're concerned about, I'd recommend taking a look here. Like I said, it does have, in our experience, this is something that scales out really well and is highly performant and comparable to other high performance agents that are out there today. The second scaling scenario I want to talk about is where you have a destination. So we're ultimately sending that data. In this case, I have a SIM that I'm sending all of my log telemetry to. It's going through our gateway. So we don't have an issue in the pipeline all the way up to the gateway, but when we send it to that storage destination, we start to see rejections or we start to see issues. And we see that problem as potentially two different things. One is you might just be concerned that it's incurring high cost, right? That is a primary concern for a lot of folks we work with. But it could also be that it's just simply unable to ingest the throughput that you're sending to it. And this will happen, and a couple of things. This is typically going to be a similar solution regardless of what the reason is, but we recommend to start filtering at the gateway or before and start eliminating the logs, metrics, traces that you don't need. Start to compress them there as well. And then if that really isn't enough to get either cost or total ingest down, then we can reroute to cold storage. So rather than sending directly to that destination, we can reroute a full fidelity copy of the data to a storage bucket. Could be in Google or in S3 or in Azure. And that data is then available to be rehydrated. So save a full fidelity copy of all of your telemetry in OTLP format to a storage bucket, eliminate as much as possible. And then if you do determine that you needed to go back and investigate an incident, you have it available. You can reroute it through your collector and then send it to the destination. The last scenario is really in the central component, and the gateway or gateway group is the primary mechanism for scaling and scaling out. And so if this component is overloaded, number one, we recommend using auto scaling groups, following pretty standard scale out principles, and then considering how you're segmenting all of your telemetry. So going back to what I mentioned before, really need to look at the location, the types of telemetry that you're sending, and how you're breaking that up into groups. So you're going to end up with multiple gateway groups at some point. And then making sure that that's in a reasonable architecture. We can talk about the ways that you can do that in a bit. But ultimately, if the gateway is overloaded or you're running into issues there, this is probably the most critical component for scaling. And it's all about following standard best practices and auto scaling your collector based on some of these principles we'll talk about. So jumping right into the gateway itself and gateway groups, this is a simple gateway configuration example. It's very straightforward. A lot of times a gateway is only going to have an OTLP receiver. So the OpenTelemetry protocol, that's what we're going to be transmitting all of your telemetry as, whether it's logs, metrics, traces, or other, it will all follow that format. So typically a gateway will have one or more OTLP receivers that's receiving data, processors that you need within that. And this could be where, this is where a lot of your telemetry processing is going to be happening. Any extensions that you need, health check is one that you're typically going to have enabled. You may have things like a memory limiter as well. And then exporters to that destination, wherever you want to route the data, could be multiple destinations here as well. A few recommendations when we're talking about scaling gateway groups. First of all, most of the operations in the collector are stateless. And that's really important. It's important to be aware of, because most of what I'm going to talk about now is how do you auto scale a collector, a stateless collector? Because it is fairly straightforward if it's stateless. Now that gets much more complicated if it is a stateful, if you're using stateful components. And in that case, what I mean is, if you're using components that maintain memory and require that you're going to the same collector for every request, then you need to add in some affinity capabilities so that there's intelligence behind each request going to individual collectors. For the sake of this, and there's some good documentation on how to handle that as you scale out. Most folks that we talk to are using stateless collectors, and that's I'd say, more typical scenario. We're going to focus on that for this. And in that case, we're really just following standard best practices for load balancing and auto scaling group. And so the easiest mechanism for that, we build out our auto scaling set of collectors. We have a load balance in front. We're going to determine how to scale that. The easiest is to, just like you would with an application, look at CPU, memory, and network IO to scale that and increase the number of collectors within that group. Again, more focused on best practices, having a minimum of 2 collectors. Ideally, you have 3 in separate availability zones or separate data centers, but in a closer or close location. That's really the ideal to start with, and then you scale from there. And having that, 2 collectors or 3 collectors in separate availability zones gives you really strong high availability and resiliency to failure. A couple of other components of gateway groups, and this is more specific to the collector itself. One is you need an indication that the collector is running, and the collector gives you a extension called health check that's made specifically for this purpose. So within your configuration, you want to make sure that you have health check enabled. There are a couple of other ways you can look at the health and whether the collector is ready to receive traffic. This is the recommended method to do that, though. You also may want to enable the memory limiter extension. One of the reasons to do this is you get some additional visibility in the metrics within the collector itself. So if you enable the memory limiter extension, you get some additional metrics like the exporter queue size and capacity, and that can be a good indication of when to scale. So I recommend usually starting by scaling out on CPU memory IO. But if you're looking for more control and really understanding when is that collector hitting max capacity, when are we approaching that, you'll probably want to look at the internal collector metrics. And these metrics are all exposed through a Prometheus endpoint within the agent itself. I'll show you what that looks like, but it's pretty straightforward to expose those metrics. Again, it gets more complex if you're choosing to follow this method, but it does give you better visibility into what's happening. I'll also say, even if you don't decide to use these for the actual scaling, determining when to scale out, it can be really useful to expose these and then monitor them as you're tuning the system and determining what the right approach is to scaling out. So even if you're not necessarily using them directly, they can be a good indication of the performance of the collectors at scale. And then, of course, I'll mention it again, but if you're using, for example, tail sampling, other stateful operations, it does increase complexity, and some of these won't apply. It will just require more consideration that you're maintaining affinity with from whatever the source agent is to the gateway and the specific gateway node that you're sending to. So once you're starting to scale out and maybe you have your first gateway group, at some point you are going to get to a point where it makes sense to separate out those gateway groups into multiple. And there are a few ways that we can do this, and a few recommended, and some that I would say are optional depending on your specific scenario. And I'd say this is the most common. It's to break up your telemetry streams by either region, breaking it up by application, or potentially teams. And this is really common in scenarios where you have a large observability team or a centralized observability team or security team, and you're working with application owners, you're working with other teams in the organization, and you want to give a team or an application owner a single endpoint to send all of their telemetry to. And that's when you would break this up by application or team, and it would look a lot like this, right? You're sending everything along, metrics, logs, traces, through that single endpoint, specifically for an application, and then that's getting sent along to all of the destinations. This allows you to do a few things. One is you can manage certain types. If you know these applications are going to have a specific type of data, you can have separate processing rules for that as it passes through. And it can also be good for standardizing your reporting. So if you're looking at things like chargeback for teams, this segmentation can make that a little bit easier. You can still do that even if it's all going through a single gateway, but this makes it a lot cleaner. So this is probably the most common. You're sending all of your telemetry to multiple gateways. This is frequently necessary or strongly recommended if you have workloads in multiple regions. Again, you want to make sure that your gateways are fairly close to the sources, just as a best practice. And so you'll frequently end up with these in different regions as well. There is another option though, and this one, while less common, can sometimes make a lot of sense depending on your scenario. This is just broken out into a simple host with 3 types of telemetry. So you have your traces, your metric telemetry, and your log telemetry going into the agent, being with some light processing before it's sent. And this is another telemetry stream strategy that you can consider. So if you have, for example, that the majority of your logs are going to a SIM, you have traces going to an APM endpoint, and you also have metrics going to storage. We can break those out and handle them in separate gateway groups, and then handle the processing for each of those streams completely separately. And that allows you to scale maybe a little bit, get your scaling a little bit more tuned, because those, the profile for each of them is going to be very similar, potentially less spiky, and make it a little bit easier to tune that. I'd say that this is a bit less common because it does, what we found is most folks end up commingling their telemetry at some point. So if you're getting logs from a certain source, it's likely that you're going to end up passing metrics through as well, and they're going to get combined. But that's not necessarily the case, and so this is certainly something you consider, and easy to implement in the same way that it is if you're breaking up by application or by team. And while I'm not showing it here, I will mention that you can do the same thing. We can break out those streams and manage them as separate pipelines within a collector group as well. But it would look very, I'm not calling that out specifically, it would be really similar to the architecture you see here. So you can already, with this architecture, split your pipelines and have each handling different telemetry. But this just makes it more explicit, and we're really saying one gateway group only handles one telemetry type. So I want to jump into BindPlane and show you how this works in practice. And then we'll have a few minutes for questions before we wrap up. So a couple notes on BindPlane. It's talks about OpAmp, the remote management capabilities of BindPlane. That's what lets you see, get visibility into the agents in real time. We're using the ObservIQ distro of the OpenTelemetry collector. And this allows us to manage gateway groups and get really good visibility into what's happening within those groups. So let me just jump in, and I'll start by building a configuration. And this is going to be a gateway configuration, gateway group. We'll apply this to multiple gateways. And it's for I'm going to break this down by region in this case, and then also the app. So it's my app 1, region is East. This is going to be a gateway group that I'm developing. For my source, I said frequently the input is just an OTLP source. So we'll save that. And I'm going to send it somewhere. Let's see, in this case, we will send logs to Chronicle. Okay, so we have a very basic gateway configuration. This allows us to ingest OTLP, do some processing, there isn't anything happening yet, and then send that to a destination. In this case, we're sending it to Chronicle, and we'll send it to one other location as well. So we'll send it to an S3 for archiving. Now I want to apply this to a couple of agents or hosts. So I've taken this gateway configuration, and now it's running on 3 separate instances. Now, for this truly to be scale out architecture, we would apply this configuration to the image. So we would give each image a label, and they would request the latest configuration from BindPlane. But when you're getting started out, we've just shown that we have 3 different hosts that are all running this same configuration. Now, a couple of things that I mentioned before. One is for a gateway, we do have a couple of extensions we recommend. I'm going to add the health check extension. So we'll save that. I'll roll that out. And so now that health check extension is available across all of these agents. And so they're ready to be moved into, or this configuration is valid now for an auto scaling group. And then next we want to get some of the metrics related to the agent itself. So we want to see how the agent's doing. This is going to pull in those agent metrics that can be used for auto scaling. So we have the health check, we can auto scale on CPU or memory, but we can also pull in agent metrics. And let's see if we have any of these available yet. This may take a minute, updates once a minute or so. So give it a second, we'll take a look. And what you'll see is internal agent metrics. And these are really useful when you're trying to understand the performance and when it might make sense to scale up or scale out. I'll also show that on each individual agent, you can take a look and get a sense of what the CPU memory usage is across all of those. And that can be really helpful when you're dialing in and tuning your auto scaling formulas. All right, so we have these now available. Look at metrics, and now we see we have metrics coming through. And they're basic things about the collector itself. CPU, we can see the queue for the exporter. It's a really useful metric that lets you know if there are anything blocking, or if there is, if the queue starts to increase, then we know that we have some concerns, some things to be focused on. Same thing with like memory, whether it's up or down, filtering. So there's a lot here, and it's worth just reviewing and taking a look at this, and then using that as you're defining how you want to scale out your collectors at scale. All right, so we have one that's this one specifically for East region, app one, and of course quickly create a new one for West region or app two. But I wanted to show one more scenario where we build one specifically for a single telemetry type. So now I want to, I'm still going to say a region because region is key, but we're going to say this East region, and this is logs only. Well, again, a source, OTLP is going to support all of those. So whatever the telemetry type, we can always use an OTLP ingestion, and we will use that format for processing. But we're going to turn off metrics and traces. So this won't accept metrics or traces. It's only going to accept logs. And we're going to do the same thing. We're going to add this S3 archive, and we're also going to add Chronicle. And then we'll add some agents. I'm just going to replace the agents that I already deployed this on. So now we've done, created a similar pipeline, similar configuration, but now it's focused entirely on a log pipeline. So this would be, we've done here is we've taken a look at both of these scenarios. The first configuration would be a configuration you would apply in a scenario like this to a gateway group, maybe tied to a region, in this case, a region and application. And the second was defining a configuration, applying it to multiple hosts with a specific telemetry type and limited to a single telemetry type. So both of those, again, very easy to do and very easy to get started with. And then, of course, the next step would really be to pull all this together, to take your agents, redirect them to the gateway, And then you're free to start adding in processors. And these processors are what we use for things like filtering and reduction, but also for routing to different destinations. And that's really all there is to it. I'll say when it comes to managing high throughput, that's really been a major focus of OpenTelemetry. It's what a lot of customers are using it for. And so it's well supported, well documented. And I'd point everyone to how you scale. This is a great section in the documentation for OpenTelemetry. It talks a lot about scaling stateless collectors. It also talks about scaling stateful collectors, which I didn't get into, and talks through some of the different scenarios there, and also gives some guidance on Kubernetes. So a great resource when you're really getting into it, and talks about some of the most advanced scenarios, how to use metrics beyond things like CPU memory, and actually look at the collector metrics themselves. So I'll pause for a minute and see if we have any questions before we wrap up for today. There's one about sharded metric collections. I can talk about what that looks like in our environment. So give an example of this. Let's see, we have a good example here. We create a new configuration. We'll start there. So we're going to create a new one, and the question here is, how do you handle and scale out with sharded metrics? And where you see this is, let's say that we have a number of Prometheus endpoints that we're scraping metrics from, and we get to a point where the agent or the instance is overloaded, and so we need to start splitting that out. And when we do that, the simplest way, and the way I would recommend for most folks starting, is to just break it down to multiples. So let's see if I can get. So I'm going to create a region A. And then my destination, in this case, we'll send that to Prometheus. So what I've done is I have, in this case, I'm scraping Prometheus metrics from a application, and then I'm sending them to my Prometheus backend. What happens if you had multiples of these? Could be Prometheus frequently may look like this. Right, so if we had multiple scrapers running at the same time, this is a simple example where it's probably obvious. Then what we would do if we found that this agent or group was overloaded, we would break this out into a separate configuration. So what I would do in this case, we can duplicate this, and we'll call it sharded metric config 2. An issue. Oh, I need to add it. Let's put it on a couple of these agents first. So in this case, we have we're gathering Prometheus metrics from a number of endpoints, and then we want to duplicate this. So what we'll do is we'll duplicate that configuration, and look in here. We add something identical to this. We can go in and then remove region B and just leave region A as it exists. So that's a simplified version of it. It could be more complex, and you could be having to filter down or limit the set that you're gathering, but it's going to be something like that. It's when you're dealing with a source that's scraping data or ingesting data from, I'll use syslog example again. If it's ingesting from multiple locations, then you may need to split that up into multiple configurations and apply it to multiple agents. There is another specifically for this challenge. There's another option as well, and it's called the target allocator. I can pull up a reference. There's Prometheus, specifically for Prometheus. It's called the target allocator. It's part of the OpenTelemetry collector config, and that can be used to automatically distribute the collection of Prometheus metrics. So this is a use case that a lot of folks using OpenTelemetry are focused on, and so there's been a lot of interest in making that simple. Any other questions today?
Doesn't look like any, Mike.
Great. Well, I appreciate everyone joining. We have one more in this series that's focused on instrumenting your code base. So it's moving away from the collector and talking about how you use instrumentation, which is really where OpenTelemetry started and is probably the most mature. So understanding things like how do we instrument the code base, how do we auto instrument, and how does that fit into your overall observability and observability pipeline strategy. So looking forward to seeing folks back then. And in the meantime, have a great day.
Thanks, everyone. Have a great day.
Thanks, everyone.